Now we're going to work with expressing a function as a composition of two functions. So in this type of exercises, I'm giving you a random function and I want you to find two functions such that if I evaluate one in the other, I will get the main original function. The trick or key for these exercises is to identify the big picture function and then what is inside of it. So in example F, notice what is my big picture function. I have a radical function. That one could be my output function or the outermost function. And what do I need to plug into this function to find the radical we have here? G function could be exactly what is inside, such that if I evaluate f in G, that is, if I plug G into f, I'm gonna get the original function. This decomposition is not unique. You can make it as complicated or fancy as you like. For example, what if instead of just choosing the radical, I choose the polynomial inside the radical like this? Then what should I plug into this function to create this polynomial? Notice that what I'm missing is that the x variable has to be raised to the power of 4. Now, if I plug G into f, I'm going to obtain the original function. Another example for this same composition could be, what if f of x is the square root of 2x? Then G of x could be the polynomial 2x to the power of 4 plus 4, such that if I plug this function into this one, I'm going to obtain the original function. Notice that for each of these exercises, you're going to have a lot of solutions. You can choose the one that you like the most. Another example. For example, here we have something raised to the power of 7. That is like the outermost function, the big picture function. So we could choose that the f function is something raised to the power of 7. If we choose that, we only have to see what do we have to plug into that x to make this original function h. So G should be x squared plus 1 over 2x squared. Thus, if I plug G into f, I'm going to find the original function h of x. Again, this decomposition is not unique. For example, f of x could be x plus 1 over 2x raised to the power of 7. So what I'm missing from my original function is the x squared. So if I plug this function into f, I will find the original function h. Another example. For this function, the big picture function is a radical function. Now, this can be a little bit trickier because, for instance, you could say, oh, my big function could be 2x minus 1 and 4x minus 2, such that g of x should be x. But this is cheating because we cannot use the input function as just the variable x. So, what we can see here is that the numerator and the denominator have something in common. Because if I factorize my denominator, we notice that my denominator is 2 times my numerator. So, what I can see is that f of x can be the function x over 2x, and g can be x minus 2x minus 1. Then, if I plug g into f, I will obtain the original function s.